Hi, I'm Shuichi Murakami. Welcome to Designing Landscape Form series. Over the past two episodes, we explored the design of landscape sequences. Among the various types of scene changes, one involved a change in the slope of the ground we walk upon. One of the factors that shapes a walker's experience is whether the ground is flat or inclined. In other words, landform. In this episode, we will learn about contour lines, the fundamental tool for understanding landform and treating it as a subject of design. If AI can automatically generate and modify landform, do we still need to understand contour lines? Yes, because contour lines are not merely tools for drawing landform. They are tools for thinking spatially in 3 dimensions. In episode 10 on landscape sequences, changes of level to inclined in ground were expressed in this way using axonometer drawing. The same condition can be represented in section as shown here. This is a landform in which the slope of the ground changes at specific points and then continues at constant gradients. When drawn in plan, it appears like this. Lines emerge where the slope changes. In other words, break lines in the landform become visible. But what about a landform in which the slope changes gradually as shown in this section? When drawn in plan, it appears like this. Because no break line appears, we cannot even tell whether there is a slope or not. What then should we do? Let us return to the section of a landform in which the slope changes at specific points and then continues at constant gradients. Let us assume that the lowest point of the ground is at an elevation of 0 meters and the highest point is at 3 meters. Within the sloped portion, there are points at elevations of 1 meter and 2 meters as shown here. When this situation is represented in plan, it appears like this. The 1 meter and 2 meter elevations within the sloped area emerge as lines in the plan. Since the ground does not actually bend or break at the 1 meter or 2 meter levels, these are drawn as dashed lines to distinguish them from break lines. They are conceptual lines that simply indicated that the elevation at these locations is 1 meter or 2 meters. Such lines are called contour lines. At the same time, there must also be contour lines indicating elevations of 0 meters and 3 meters. Yes, one could say that the 0 meter and 3 meter contour lines overlap with these break lines. Furthermore, to the left of the 0 meter contour lines and to the right of the 3 meter contour lines, we can imagine that countless additional contour lines of 0 meters and 3 meters exist. Now, what about a landform in which the slope changes gradually? Let us assume the section where the lowest elevation is 0 meters and the highest is 3 meters as before. Points and 0, 1, 2, and 3 meters appear along the section in this way. When represented in plan, these elevations emerge as lines like this. Because the landform does not break at any point, The contour lines are not hidden beneath any solid break lines. Up to this point, as shown in this axonometer drawing, we have understood landform from the perspective of a person walking. We have viewed the landform linearly along the direction of movement. However, landform does not extend only in the direction of movement. It continues in multiple directions. In other words, we need to understand landform as a surface. Let us therefore consider the surface of the landform as a bundle of sections. In this example, the path can be understood as a bundle of same sections. Only 4 are shown here, but imagine that there are infinitely many. If the same change in slope continues on both sides of the path, then this bundle of same sections spreads outward in both sides. The contour lines also extend accordingly. However, the sections along the path and on either side are not necessarily same. There may be landforms in which one side rises while the other descends. When we understand landform as a bundle of sections in this way, the meaning of contour lines becomes clear. A contour line is a line formed by connecting points of equal elevation. The surface of a landform can be understood as a collection of countless points. The plan above shows only some of those points. The elevations vary from one another. Let us connect the points that share the same elevation and draw contour lines. We are able to connect elevations at 101 meters, 102 meters, 103 meters, and up to 108 meters. Now, let us draw in section below the landform as it would be experienced by someone walking through this place. First, we prepare horizontal reference lines marking elevations from 101 meters to 108 meters. Next, on the plan, we draw the path that the person might walk along. We consider this line as a section line that cuts through the landform at this location. From each intersection between the section line and the contour lines, we project vertical lines downward to the sectional drawing and identify their corresponding elevation marks. Then, we connect these points with a smooth curve. In this way, the sectional profile of the landform emerges. We can now see that as this person climbs the slope, the gradient becomes steeper up to around 105 meters, and beyond that point, the slope gradually becomes gentler. Now, as we looked at the profile line together with the elevation marks, do you notice something? Yes. The landform can be understood as a stack of horizontal planes, each defined by contour lines. Here is today's summary. Contour lines are drawn by connecting points of equal elevation. They are a fundamental tool for understanding landform. The experience of a person walking across a landform can be understood by drawing a section along that person's path of movement. Furthermore, A landform can be understood as an accumulation of countless sections imagined along possible paths of movement. At the same time, it can also be understood as a stack of horizontal planes defined by contour lines. A complex and ungraspable landform can be represented and understood as layers, both horizontally and vertically. And this way of seeing and drawing landform becomes the foundation for designing landform while considering the experience of those who walk upon it. In the next episode, we move from understanding landform to design it. Let us explore how shaping the ground can shape human experience. The ground is a surface that supports our bodies. When the surface rises or falls, our movement and perception shift. See you in the next episode.